When we think of a wave, we typically think of something that oscillates up and down and eventually returns to its original state after its source has calmed down. For example, if we're relaxing in a swimming pool and our friend here decides that they're gonna shake things up with a cannonball, we expect that after their antics have ended, the pool will once again become flat and calm. It would be pretty weird if after this disturbance, the water in the swimming pool ended up being permanently curved and contorted like a big piece of misshapen jello. Well, obscurities such as this do exist in nature. And while they may not happen in our swimming pools, they happen in the very space-time in which we exist. A gravitational wave is kind of like the waves created by our friend's cannonball, but instead of propagating in water, they propagate through the fabric of space-time. And instead of, instead of being created by cannonballs, the most common gravitational waves are created by orbiting black holes that merge. Furthermore, when a gravitational wave passes through space-time, things don't always return to normal. Instead, a gravitational wave leaves behind a memory of its passage, as shown in this figure here. It's as if the water in the swimming pool ended up permanently looking like the aftermath of our friend's plunge. But what's even more intriguing about memory is why it exists in the first place. In physics, we often care about symmetries because for every symmetry, there is a corresponding balance law between a flux and a charge that we can take advantage of. For example, if we have a cup of hot coffee sitting in a room, then a symmetry of this system is a change in time by a constant amount because the contents of the system and the laws that they obey are independent of time. As a result, the radiating heat, the flux, is balanced by a change in the coffee's temperature, the charge. What's special about memory, though, is that the symmetries it's related to only exist at the edge of the universe. Therefore, memory can not only teach us about the fluxes and charges associated with gravitational waves, but also about the fundamental structure of our universe. My research is focused on producing expectations of memory that we should see here on Earth due to black holes that are merging all throughout the universe. To do this, I have to solve Einstein's 10 equations for merging black holes. And naturally, this is pretty hard to do on pen and paper. So instead, I solved these equations on a computer-generated spacetime. By obtaining a better understanding of memory, I hope to help detectors such as LIGO observe memory for the very first time so that we can not only study the edge of the universe, but also come to understand the symmetries associated with classical and quantum gravity, and thus inch closer to a complete theory of physics. Also, with a better understanding of memory, we may be able to create regions of space where time flows slower. Who wouldn't love a room where they could sleep for 10 hours while the rest of the world only experienced 8? Thank you.